Okay, I didn't explain one of my thoughts very well, so I'm going to see if I can just uh, paste this video onto it. What I was trying to say about how the the process is the same or the data set is different. What I meant by that is like um, you can what they would do then, like let's say, is they would have some kind of like a speculation about the universe, the world, um, and they would, if they were able, kind of try to test the hypothesis. Like I don't remember who it was. One of the early philosophers had a hypothesis that everything is made of water, and the reason why he said that is because, well, water can be liquid, it could be solid, it can be a gas. So it's all of those things. It can be all of those things. So it must be the material that makes up the entire universe. Um, and Pythagoras said the world is made of number. I don't know if he meant that in the same way that the guy that, I don't remember, was it Thales? Is it about water? I wish I'd looked that up before I started recording this. I don't remember. And then there was a guy named Democritus that said, okay, so there's these little tiny units um, that make up the entire world, make up everything, and these different compositions of these units make these things up. And he called those things atoms, and atom means indivisible. And you say, oh, so he was the one that he turned out to be right. Actually, no, because the word atom means indivisible. Well, we know now that atoms are divisible. Not only that, they divide a lot. Not not on Earth. I mean, whenever we make them divide and fuse, we can do that. But in stars, they divide all the time, and they even break down into different states of matter. Look up what a neutron star is sometime. It's pretty interesting. Um, there's even a kind of neutron star called a quark star, where it breaks down even further than the subatomic part. Well, I guess they're all subatomic, but anyway. And so the point that I'm getting at is that they would make these hypotheses, and they would debate them. They would, and if they could, they would see if they could test them. Now they didn't have the abilities to test a lot of these back then, so that was what we would today call fringe science. Fringe science doesn't mean wacko science. Fringe science means we have no way of testing this. It's way out there. Maybe one day, but right now it's such wild speculation that we have no idea. Um, and anyway, um, but that same process is used today. Like there is a we make a speculation, we make a hypothesis, and when we can, we test that hypothesis. Newton came up with a law of universal gravitation, genius law, turned out to be wrong, sort of, because it was replaced because it was not complicated enough. It was replaced by Einstein's theory of general relativity. And some discoveries are made from deductive reasoning, like a lot of discoveries about black holes are made by plugging things into Einstein's equation. Don't ask me to explain Einstein's equation because I don't know. Maybe one day I'll look into it. I just know it's not very easy to think about. And some things that we learn uh, just by observation. So we have a hypothesis, so we could test that hypothesis from observation. It was the same process back then. It's just that we have a lot more data today compared to back then. That's why we know so much more. We know that they knew back then that the Earth was round, but now we know that the Earth moves because we have the more data to support that. We've been able to analyze the data. But if they had that data back then, they would have been able to have that same reasoning ability. So, I think I'm just going to upload this as a separate video because I don't want to go to the trouble of figuring out how to merge them into one video. I could do that with FFmpeg, but I have to look it up every time, so I don't want to do that.